Hello students, today we are looking at the changes of range, IQR and SD when removing or adding a datum to a set of data. So first, let's look at range. Here we have a set of data. First of all, we can find the range of it. So it is easy, you find the largest minus the smallest, so you get 25. So now, in case 1, if we try to remove 17, which is the smallest value, then what will happen? Then you can see the new range will become 42 minus 23, and you get 19. So it is decreased compared with the original range. So now we go to the second case. If 42 is removed, what's the new range? So you can see, although one of the largest value is removed, but there's still 142, right? So we still have the maximum is 42. And then we minus 17. So you get 25, which is unchanged. And then now, if we try to remove the 32, which is in the middle of the data, you can observe the range has not changed, obviously, right? Because the largest value and the smallest value has not been removed. So actually the new range is still 42 minus 17, which is 25, unchanged. So from these 3 cases, have you observed or can you discover when will the range be changed? Yes, it's only when the smallest value or the largest value, and if it is the only one, then the range will decrease. But actually the range will never increase. So let's come to the first conclusion. The range decrease only when an unit smallest or largest datum is removed. That's the only one. So when you remove it, then the range is decreased. So let's go to the part. Does the range change by adding a datum? Again, we use this set of data. Imagine when you add the values into this, then it will not affect the maximum or minimum. So the range will not change if you add some values between the smallest and the largest. So when will it be changed? Is if you add some value smaller than the smallest one or bigger than the largest one, then the range will change. So here we come to the second conclusion. The range increases only when a datum larger than the largest datum or smaller than the smallest datum is added. Okay, got it? So let's also highlight the previous one. So now we go to the IQR. IQR. So again, we use the same set of data. But this time, let's try to look at IQR instead of the range. So first, we can find the IQR of this set of data. Do you remember how to find the IQR? You cut it into half, and then 42 is Q3, 23 is Q1, so we get 42 minus 23, which is 19. So now if 23 is removed Then what is the new IQR? So again, if there are only 5 numbers, so 36, we cut it, and then 42, and 42, and this is between 17 and 32. So the new IQR will be this one. So we get 17.5. So it is decreased compared with the original one. So now we go to the second case. If 32 is removed, so again we get 36, and then 42 and 42, 17 and 23, which is the Q1. So the new IQR will become 22 plus 22 again over 2 minus this. And in this case, you get the answer is 22. So this is increased this time. Now look at the last case. If one of the 42 is removed, now let's say this one, then we get this. Okay, 32, cut it, and then Q1 and Q2, Q3. So the new IQR is equals to 36 plus 42 over 2 minus 17 plus 23 over 2. And then in this case, we get 19, so which is unchanged compared with the original one. So actually you see the situation can be decreased, increased, and unchanged, and there's no pattern to observe. So to find it one by one. So that's here we come to the conclusion. IQR can only increase, decrease, remain, and change. When you remove a datum, so same as you add a datum. Here I won't show you adding the datum, but you can imagine it is similar. Now let's look at the SD part. SD, it takes all data into account, right? So you can imagine SD actually can increase, decrease, or remain and change when the datum is removed or added. So here I want to introduce one very important golden rule, which is about remove a datum which is equal to the mean. So this is quite important. So what will be happen? Now consider this set of data 2, 3, 5, 6, 9. Now we get a mean, is 5, and then we get the SD formula. So you observe this 5 minus 5 square, is 0, right? So here we won't, in the next step, we don't have this term. And if we first keep the formula in this way. Now if we remove the mean, means the 5 from the data, if we try to remove 5, then you get the new mean is 2 plus 3 plus 6 plus 9, right? So because we remove 5, the data set becomes this 4 only, and then over 4. So you still get 5. And then let's look at the SD. So the formula 2 minus 5 square plus 3 minus 5 square plus 6 minus 5 square plus 9 minus 5 square, and then over 4. So can you see that? Actually the denominator here is exactly the same as the numerator is exactly the same as the numerator of the previous one. But what is the difference? Is the denominator. Because the denominator is decreased now, so the new SD will be bigger than the original one, right? So the new SD is bigger than the original SD. So let's come to the conclusion. When you remove a datum which is equal to the mean, then the SD must be increases. So this is for you to remember, okay? You just remember when you remove the datum, then the total number of data is decreased, so the denominator decrease, but the numerator is unchanged. So when the denominator decrease, then the SD will increase. Okay, similarly, on the other hand, if you add a datum which is equal to the mean, then the number of data increase, okay, while the numerator is unchanged, so the SD will decrease. Okay, so here today we get 5 points. Okay, let's go back so we can have a review. So the first, the range decrease when an unit smallest or largest datum is removed. And the second, the range increases only when a datum larger than the largest datum or smaller than the smallest datum is added. And the third one is about the IQR. It can increase, decrease, or remain unchanged, so actually you need to find it every time. So the last two is about SD. Only when a datum equal to the mean is removed or added, then you can apply this formula. Okay, so I hope you can get more understanding. Now it's your turn to do the quick practice. 9.17.